So I had a lot of people confused on the bonding thing. I thought I did a good job in the last video, but I'm going to give you some quick help if not. First thing, you need to understand where to recognize things like metals to non-metals. So this is what this video is on. So when I talk about metals, so everything in these first two columns, the alkali and alkaline columns, are metals. Now, every now and then you might see a compound done with boron and aluminum as well, but for the most part, it's just these two columns over here. Okay, all of this stuff in the middle here are transition metals, and we're not worried too much about transition metals. And even these in the green here, which are considered basic metals or sometimes post-transition metals, they act more like transition metals, so we're not going to worry too much about them either. So those are our metals. Okay, so I'm going to put big M on them for metals. All right. When I talk about non-metals, I'm only talking about these right here. These are our non-metals. Okay. And when I'm talking about an ionic bond, I'm talking about its charge. And we're going to get its charge from the periodic table here. So here we have two elements. We have calcium and oxygen. Calcium is a metal. Oxygen is a non-metal. But see, right now they're just elements. We need to figure out their charge. And before I bring back the periodic table, I'm going to draw a small representation of it just so you understand. Okay, so let's think about the periodic table this way. So if you look here, we're only concerned with certain columns, the ones that stick out above. All these transition metals, we're not going to count those when we're counting columns. But each column is going to represent what charged ion the elements in that column are going to fall into. So over here on our metal side, we have that lithium and beryllium, alkali and alkaline metals. Here's boron I put over here, and carbon. And then our non-metals over here under nitrogen, oxygen, fluorine. Any of our noble gases aren't going to create ions, so we don't worry about those. So what you need to be able to do is look at the periodic table this basically and be able to count up to three or to four. 1, 2, 3, 4. Okay? After that, you need to count down 3, 2, 1. And if you can do that, you basically are saying you know the charge. Because here's the thing. With these, everything in this first column is going to be positive 1. Everything in the second column, positive 2. Boron's really the only one you're going to use. It's going to be a positive 3. Carbon's the main thing you're going to use here. It's actually going to be a negative 4 because we're probably going to use it as a non-metal because it is a non-metal. And then negative 3 in the nitrogen, negative 2 in oxygen, negative 1 in fluorine. So whenever we're doing the most basic version of these, you're just going to get your charge by looking at the periodic table and seeing where these things are. Okay? So to do that, look back at the periodic table at what we had. Here's calcium. On the second one, remember that one was positive 2. So calcium is going to be positive 2. And oxygen's over here. This one's 1, 2, 3, 4, 3, 2, negative 2. Oxygen's negative 2. So that's where we get these charges from. The ion that calcium would make and the ion that oxygen would make. Calcium makes a positive 2 ion. Oxygen makes a negative 2 ion. And it all has to do with how many electrons they give off and their valence shells, if you learned that in the last unit. Okay, but this is the point you need to get to start doing the bonding. This is also known as the oxidation number, even though it's just a charge, okay? Notice that I have the cation, that's the positive one, first. It always has to come first. Remember that rule. Step 1, list your charges. Step 2, list the ion that's positive first, okay? Step 3, write both of them down again below it. That's CaO, but without any charges whatsoever. Now we're going to do the cross-oxidation method. Don't get confused by that. All we're really doing is I'm going to take this 2 and just the number, no plus or minus, okay? I don't know how many times I gotta say that, but people are still doing that. And you're gonna make it a subscript here for the opposite element, for oxygen. So that means that 2 in calcium becomes a 2 on oxygen. Likewise, the 2 over here for oxygen is gonna become a 2 subscript, no charge, no negative, for calcium, okay? They go to the opposite element. It's now a counter. So up here it was a charge. Now it's a count of how many oxygen I need. I needed 2 oxygen, and this one went over to this one. I needed 2 calcium. Know if this was a different element and this was nitrogen, that's -3, that 3 would become the subscript for calcium, okay? So you're just bringing down and crossing over to the other element. Don't drop it straight down. It has to go from one element to the other, becomes a subscript, and it doesn't have a charge, okay? That's what we call the cross-oxidation method. Now our next step is we have to reduce those subscripts. So is there a number that divides into both 2 and 2? Well, 2 divides into both of those, right? And it's going to go 1 and 1. So that means I'm going to get Ca1O1. But here's the other thing, and this is the last rule for making the formula. If it's a 1, I wouldn't have written the symbol for that element if it wasn't 1. So to save scientists time, we don't write 1s because you're already writing the symbol to represent it. So that means that you would actually write CaO as the proper formula for that, okay? Now, that's what it is. And so think about the steps again. Step 1, find the charge of each on the periodic table by what column it's in. Step 2, write the cation first, okay? It has to come first in the formula and the name. All right, step 3, take the charge of the first one and make it a subscript of the second one. Take a charge of the second one and make it a subscript of the first one. So it crosses elements, right? And it doesn't have a charge anymore. It's just a number value. So 2 and 2, okay? No negatives, no positives. 4, divide and reduce those coefficients. If they don't reduce, you don't have to do this. But when they do, you do. Last step, 5th step, get rid of 1s. They need to be left blank, okay? And so if you're taking the quiz, if you have a 1 for 1, you need to put blank, not 1, all right? Now, as far as naming this goes, you're just going to take these elements as they're listed in your formula now with that positive one first. And the first one is just going to be what it appears on the periodic table. So copy it off, but use lowercase. Calcium is calcium, okay? The second one is the only one that's slightly odd. So oxygen, your non-metal. Your non-metals, you have to change the ending to end in IDE, okay? And it usually happens almost always at the second vowel, and Y counts as a vowel. So with oxygen, you would have oxide, okay? Instead of oxygen, it becomes oxide. It's a little bit different too. The only other one, because it's almost always at the second vowel, you replace the vowel with IDE, or the rest of the word from that vowel with IDE. The only real exception is fluorine that has a U and an O side by side. So you're still going to have fluoride, so it's after the R that you do the ide. Let's do one more real quick from the top just to make sure you got it. All right, this time I'm going to look at nitrogen and sodium. I'm going to find them first on the periodic table. And to do that, so, all right, there's sodium and there's nitrogen. Let's do my trick. 1, 2, 3, 4, 3, 2, 1. These are negative. These are positive. So that means that sodium is going to be a positive 1, and nitrogen is going to be a -3. Step 1, found the charge. Step 2, write my positive one first. It's going to be added with negative nitrogen. All right. Step 3, write them again and bring those numbers down to the opposite one to be subscripts. So 3 goes there, 1 goes there. See how they switched elements? All right. Now, step 3, reduce. Well, nothing goes in 3 and 1 but 1. However, I do need to do the final step, get rid of anything that's a 1, so it's a blank. So this is now my formula. For sodium, I have 3 sodium to 1 nitrogen. Now naming it, sodium, just disappears on the periodic table. Nitrogen, I have to end with IDE, nitride. And that's all it is.